Paper number 5 discussion. Paper number 5 discussion, pure paper. Pure paper. Okay. You check your answers with me. Question number 1, part A. In a triangle PQR, R angle given pi divided by 2. Now here the triangle PQR, R angle 90. AX squared plus BX plus C equals 0, roots tan alpha over 2, tan beta over 2. Here not equal to 0. A not equal to 0. Then here alpha plus beta, before that, here write root sum tan alpha over 2 plus tan beta over 2. B divided by A minus B divided by A. Then root product tan alpha over 2, tan beta over 2, C divided by A. Here relation between roots and coefficient. Relations between roots and coefficients. Coefficients. Now here PQR 90 now. Then P plus Q angle. P plus Q angle. Here P over 2. P over 2, Q over 2. Here P over 2, Q over 2. P over 2, Q over 2. Then P plus Q angle pi divided by 2. Then P over 2 plus Q over 2 pi divided by 4. Then you write tan P over 2 plus Q over 2. By this one, write tan pi over 4. Tan P over 2 plus tan Q over 2, 1 minus tan P over 2, tan Q over 2 equal 1. Tan P over 2, tan Q over 2, sum minus B over A. Minus B over A, 1 minus root product C over A. Cross multiply, minus B over A, 1 minus C over A. Then take this side and multiply by A. Minus B, A minus C. Then A plus B equal C. A plus B equals C. Completed. Then question number 2. Show that the sum to nth term of the series 1 plus 2, then 1 plus 2 plus 3, it goes like that. Here U1, here U2, here U3. Then Un will be 1 plus 2 plus 3 plus n sum. Then first n integer sum. Here you can consider mathematical induction or you can consider series as well, both possible. Then 1 to n sum, write n over 2 n plus 1. By the series you can write n over 2 n plus 1. Then Sn equal u1 plus u2 plus u3 up to un. Then u1 put 1 here, 1 times 2 over 2, u2 put 2 here, 2 times 3 over 2, u3 put 3 here, 3 times 4 divided by 2. Then un, n plus 1 over 2. Okay. Then 1 over 2, 1 into 2, 2 into 3, 3 into 4, n into n plus 1. Here you need to get sum of this series. Okay. Then further get u dash r plus 1. Here r plus 1. Therefore fr r plus 1, next term r plus 2. A times here fr. Then u dash r equal f r minus fr minus 1. Here method of difference. Then u dash r equal r plus 1, fr here a, r plus 1, r plus 2, fr minus 1 a, r minus 1, r plus 1. Now simplify. Then cancel ar. Then a equal 1/3. A equal 1/3. Therefore, fr equal 1/3 r plus 1, r plus 2. Sn equal fn minus f0. By the method of difference, Sn equal fn minus f0. Fn put r equal n, 1/3 n, n plus 1, n plus 2. Then here sum of these parts, Sn. Sn equal, we have another half value, half into half. Then 1/6, n plus 1, n plus 2. Okay. That is question number 2. Then question number 3, arithmetic mean relation with geometric mean. Consider root x minus root y to the power 2. We know that is greater than or equal 0. Here define xy, positive real value, when x equal y equality there. Therefore, here x plus y, 2 root x root y greater than or equal 0, then x plus y greater than or equal 2xy half. Then the relation is now okay. Now by this one you can deduce arithmetic mean, geometric mean relation. Let x equal a, y equal 1 over a. Therefore, here a plus 1 over a, 2 a into 1 over a to the power half. A plus 1 over a greater than or equal to. Then let x equal a divided by b, y equal b divided by a. Then substitute here a divided by b plus b divided by a greater than or equal to a divided by b times b divided by a to the power half. Take this relation. Then a over b plus b over a greater than or equal to. Then equality for a equal b. That is question number 3. Okay, complete up to that. Arithmetic mean, geometric mean, though they are very special types. Usually not comes with advanced level paper. These are special questions. Then question number 4. Mathematical induction question 2, 6, 18, 2 times 3 to the power n minus 1, 3n minus 1, 3 to the power n minus 1. Let n equal 1, left hand side 2, right hand side 2, 3 to the power 1 minus 1, 2. Therefore, left hand side equal right hand side. Therefore, true for n equal 1. Let the relation is true for n equal p, p positive integer, p in between 1 to n. Therefore, 2, 6, 18 up to 2 into 3 to the power p minus 1, 3 to the p minus 1. Here data. When n equal p plus 1, 2, 6, 18, 2, 3 to the power p, 3 to the power p plus 1 minus 1. You need to prove this one. Then proof for 1, add here this extra term, 2 times 3 to the power p, add it. Then 2, 6, 18, 2 times 3 to the power p minus 1 plus 3 to the power p. Here add this extra term with this. 3 to the power p minus 1 plus 2 times 3 to the power p. Then take these two together. 3 to the power p common, 1 plus 2 minus 1, here 3 no. Then 3 to the power p plus 1 minus 1. Now here this is there. Therefore say, therefore true for n equal p plus 1. Then final statement, therefore by the principle of mathematical induction, the relation is true for any positive integer of n. Integer of n. That is question number 4. Okay, complete it. Okay, here this section, first term 1, second term 1 plus 2, third term 1 to 3 sum, then fourth term 1 to 4 sum. Then likewise, here u1, u2, u3, that is the series. Then nth term 1 to n sum, right? 1 to n sum, n over 2, n plus 1. Then previous series, you can get addition of these type of terms sum, u1, u2, u3, up to un sum. Then same series, you can write this way. Now here you are, put n equal 1 first. Here first term now, 1. Here second term now, 2 times 3 plus 2, answer 3. Okay. Then here third term, 6. Here 6 now. Same series, different way. Okay. Then get addition, then successive integer product there. Two successive integer here. Get sum. Here two successive integers now. Then here take UR, R into R plus 1. Then take FR, here UR no, successive factor product. Then A into R plus 1 into next factor. Then U dash R equal FR minus 1 pattern. Find A value. Here FR. Then Sn usually we say Fn minus F0 and we have half outside. Fn minus F0 times half. Then Fr known, substitute R equal N, substitute R equal 0. That's the sum. Okay. Now let's try question number 5, limit question. Here limit x goes to pi over 2, 1 minus tan x over 2, 1 plus tan x over 2, 1 minus sin x divided by pi minus 2x cube. Here let's write this way. Limit x goes to pi over 2. Here 1 write tan pi over 4 minus tan x. Here 1 plus tan pi over 4 into tan x over 2. Further, here write sin pi over 2 minus sin x. Here take 2 outside, 2 cube 8. Then pi over 2 minus x cube, this way. Then here 8 no, 1 over 8. Limit x goes to pi over 2. Here tan pi over 4 minus x over 2. Here again take minus outside as well. Then write use CD 2 cos C plus D over 2 sin C minus D over 2 here pi over 2 minus x cube over, okay, that's it. Then minus 1 over 8, limit x goes to pi over 2. Here write sin pi over 4 minus x over 2. Then put cos pi over 4 minus x over 2. Here 2, take outside. Then 1/4. Cos pi over 4 plus x over 2. Okay, then here better write here sin here pi over 2 minus pi over 4 minus x over plus x over 2. Cos turn into sine. Change angle pi over 2 minus theta. Cos change to sine pi over 2 minus theta. Then here this will be pi over 4 minus x over 2. Then here sine here pi over 2, pi over 4. Pi over 4 minus x over 2. Now here pi over 2 x cube. Okay, now we can proceed. Now let's write minus 1/4 limit x goes to pi over 2. Take this part, sine pi over 4 minus x over 2. Here sine pi over 4 minus x over 2, sine pi over 4 minus x over 2. And cube with this one take outside, pi over 2 minus x cube. Then remaining this part, limit x goes to pi over 2, 1 over cos pi over 4 minus x over 2. Okay. Now here pi over 4 minus x over 2. Then you put 4 and 2. To remove that one, need to multiply by 2 here. Need to multiply by 2 here. Then 2 here cube. No? Then multiply by 8. 4 into 8. Here 3. Here we put 2. No? 2. To remove that 2, you need to put 2 here. Then 2 cube we have. Then take it outside. 8. Now by the theorem, here this part 1. Then 32. Here 1. Here cos 0 1. Then answer minus 1 over 32. Answer minus 1 over 32. Then question number 6. Y equal tan x plus sec x to the power n. Then dy over dx n tan x plus sec x to the power n minus 1. Then tan derivative sec qua, sec derivative sec x tan x. Then dy over dx n tan x plus sec x to the power n minus 1. Here take sec outside, sec x plus tan x. Then dy over dx n tan x plus sec x to the power n sec x. Dy over dx, here ny sec x. Ny sec x. Okay. Continue. Question number 7. Minus 2 to plus 2, 1 minus modulus 1 minus x modulus dx. Minus 2 to plus 2. Here intercept 1, y, 1. Minus 2. One minus 2. Then minus 2 corresponding value 3. 3. So we need to find this area, minus 2 to plus 2. Then just write half into 1, 2, 3. 3 times, here 3. Half into 1 times 1. 5. Yeah, answer 5. Modulus function integration. So I use here definition. So definition means 1 minus x function bounded area with the x-axis with the given region. Then minus 2 to plus 2. Minus 2 to plus 2. Here bounded area. Straight line stuff. Then we can easily find area bounded by the lines. Okay. Do up to that. That is question number 7. Then question number 8, straight line question. Question number 8. Find the equation of the straight line through the point of intersection. Here x minus 3y plus 1 0 and 2x plus 5y minus 9 0. Here the line. So here take x-axis, y-axis. Here perpendicular distance given root 5. Then first write this equation, say L u1 plus lambda u2 equals 0. Here this line passing through intersection point of these two lines. Therefore u1 plus lambda u2 equals 0. X minus 3y plus 1 plus lambda 2x plus 5y minus 9 equals 0. Here the equation now. 1 plus 2 lambda x. 5 lambda minus 3 y. 1 minus 9 lambda 0. Here general form. So now distance, perpendicular distance from the origin. Here point 0, 0. We have direct formula to get perpendicular distance from a given point. Then here substitute 0, 1 plus 2 lambda times 0, 5 lambda minus 3 times 0, 1 minus 9 lambda modulus divided by 1 plus 2 lambda square 5 lambda minus 3 square root. Now that value root 5. Perpendicular distance formula. Here it is. Ax plus by plus c equals 0. Here point alpha comma beta. Then perpendicular distance we write d a alpha plus b beta plus c modulus over a square plus b square root. Here it is. Then here the line, here the point, alpha comma beta. Then same relation, here the line, the point 0 0, then 0 0 substitute here and here, then we get 0 0, 1 minus 9 lambda modulus, here a square plus b square root. Direct formula. Now simplify this one. Then let's do here. 1 minus 9 lambda modulus 1 plus 2 lambda, 1 plus 4 lambda plus 4 lambda square plus 25 lambda square minus 30 lambda plus 9 root equal 5. 1 minus 9 lambda square. Then square both sides for 29. 26, 10 equal 5. Simplification ටිකක් hard වැඩි. හරිද? මේ ඒ වුණාට කරගෙන යන්න. Cross multiply 1 plus 81 lambda square 18 lambda 5 29 lambda square 26 lambda plus 10. 81 lambda square minus 18 lambda plus 1 145 and take all here. (64 lambda squared). (112 lambda 49 0 8 lambda minus 7 square 0 then lambda 7 over 8 කතාව ලොකු වුණාට අන්තිම වැලියු එක හොඳට එනවා 7 over 8 that is lambda value then find the equation therefore take this relation put lambda by Stokes equation here the equation 22x y 55 0 then divisible by 11 2x plus y minus 5 equals 0 here the equation 2x plus y minus 5 equals 0 okay complete okay then question number 9 circle question here there are two circles so here first circle x squared plus y squared plus 2gx plus 2fy plus alpha 0 here the other circle x squared plus y squared plus 2gx plus 2fy plus beta equals 0. Show that the length of the tangent drawn from any point on the circle, here first circle, then sketch tangent, then here this length. We need to get this length. Let's say D. Take this point x bar, y bar. Then we know direct theorem for length of the tangent. We have direct theorem. Take this part of the circle and substitute this point. Then x bar is square, y bar is square, 2g x bar 2fy bar plus beta root. Here the perpendicular distance. And further x bar y bar on this circle. X bar y bar on this circle. Therefore substitute x bar square, y bar square, 2gx bar, 2fy bar plus alpha 0. Then for this part, you can say minus alpha. Then for this part, say minus alpha. Then beta minus alpha root. Here alpha no, minus alpha root. Then beta minus alpha root, perpendicular distance. So when you apply direct theorem, then you can obtain it. Then question number 10, cos inverse x plus, we need to prove this one. Then let pi over 2 minus cos inverse x, then here alpha, pi over 2 minus alpha, put sin inverse sin pi over 2 minus alpha. Then sin 90 minus alpha cos, sin inverse cos alpha. Then alpha cos inverse x, cos alpha x. Then sin inverse x, sin inverse x. Then pi over 2 minus cos inverse x equals sin inverse x. Okay. Then further given sin inverse x plus sin inverse y 2 pi over 3. Then we need to convert that into cos inverse. Then for this part write pi over 2 minus cos inverse x. Here pi over 2 minus cos inverse y 2 pi by 3. Then subject cos inverse x plus cos inverse y. Here pi minus 2 pi over 3. That is pi divided by 3. That is pi divided by 3 equal to pi divided by 3. Okay, complete. ඔයාලට A level paper එකේ දැන් කරන්න බැරි part A question එකයි තියෙන්නේ. binomial එක විතරයි තාම. binomial expansions විතරයි. මම ළඟම අර permutation combinations වල questions කරන්න ගන්නවා මේ ඒක කරපු questions ගන්න මදි හින්දා ඒකේ වෙනම question series එකක් කරන්න. Okay. Complete that. Okay, let's move to question number 11 now. Question number 11. Question number 11, part A. Here ax squared plus bx plus c equals 0. One plus alpha square, 1 plus beta square. We need to show that they are always positive. Always positive. X squared plus x plus 1 surely positive if x value real. Then here this part, by the complete square method, alpha plus half square plus 3/4. No? Here beta plus half plus 3/4. If alpha beta real, alpha plus half square plus 3/4 greater than 0, beta plus half square 3/4 greater than 0. Then 1 plus alpha square, 1 plus beta square greater than 0. Then here that must given roots are real. That is not given here, but anyway need to give roots are real, otherwise we can't say roots are real. Then part B, x minus a, x minus b, x minus b, x minus c, x minus c, x minus a, 0. Rows of the equation are real if ABC equal, they all equal. Then get quadratic equation 3x square 2a plus b plus cx plus ab bc ac 0. Here the equation. Now check delta. B square minus 4 ac ab bc ac. Now simplify, take 4 outside, expand a square plus b square plus c square plus 2ab 2bc 2ac 3ab 3bc 3ac for a square plus b square plus c square minus ab minus bc minus ac. Still we can't check the sign. Then you put 2 inside. 2a square, 2b square, 2c square, 2ab, 2bc, 2ac. Now rearrange. A square plus b square minus 2ab, b square plus c square minus 2bc, a square plus c square minus 2ac. Then a minus b whole thing square, b minus c whole thing square, a minus c whole thing square. Now therefore perfect square sum delta greater than or equal 0. Delta greater than or equal 0. Roots real. Therefore roots real. When a equal b equals 0, c same, then delta 0. When a equal b equals c, delta 0. Then roots are real and equal. That is 11 part B. Okay, then part C question. Part C. Gx comma y. We are given two variable polynomial 6x square xy ky square 11x 43y 35. Here this can be expressed as product of two linear functions. Linear function means ax plus by plus c. Find the value of k. So you better to get complete square here. Let's consider 6x square y minus 11x ky square 43y minus 35. Now here quadratic function. Get complete square. X square y minus 11 over 6 ky square 43y 35 over 6 x plus y minus 11 over 12 square ky square 43y 35 over 6 minus y minus 11 over 12 square. Okay. Now here we have perfect square. Then you simplify this one. X plus y minus 11 over 12 square. Here 144. Here 6 no. Then ky square 43y minus 35. Get common denominator 144. 12 times 12, 144. Then here 24. Get common denominator. Y minus 11 square. Simplify little. X plus y minus 11 over 12 square. 144. Here 24k, here y square minus 1 y square. 43 times 24 y, here minus 22y, here plus 22 y. Here 24 times 35. 24 times 35 plus 125. 121. 11 squared. 121. Here minus. Okay. Now simplify further. 6 x plus y minus 11 over 12 square. Take minus outside. Then 144. Then here this will be 1 minus 24k y squared. Here minus 4324. $1,054 y 2 10 32 44 52 54 y. Then here plus 24 35. $840 121 961. Okay, here the relation now. Now same expression, here same expression, we can convert it up to here, perfect square minus something here. So if this one perfect square, then we can write as product of two factors. Then here delta must be 0. For this function, delta must be 0. Then take delta 0. V square minus 4 A C equals 0. Now you can find k value. You can find k value. Simplify. Here the value. ටිකක් කතාව දිගයි. ඕක තව ඇනලිසිස් එකක් තියෙනවා. හරිද මේකට? හැබැයි ඒ ඇනලිසිස් එක හැම සැරේම හරියන්නේ නැති හින්දා මම මේක කිව්වේ නැහැ. මේක linear factors විදිහට ඔහම දාගන්න. ax by c a dash x b dash y c dash. ඔන්න ඔහම දාගෙන value guess කරන්න. 6 2 3 6 1. ඒ විතර value guess කරලා ගන්න පුළුවන් coefficient equal කරලා. හැබැයි එතන combination එක ටික අමාරු හින්දා තමයි කොහොම වුණත් simplify කරලා numerical value එක ලොකු වුණාට කරන්න පුළුවන් මෙතනින් ගියොත්. linear factor product එක. complete square මෙතන minus අරගෙන මේක perfect square කරනවා. එතන perfect square වුණොත් delta 0 වෙනවා. එතන delta 0 කරපු එක කරේ. Okay, do up that. minus 11,532. පොඩක් simplification බලාගෙන යන්න. හොඳ ආන්සර් එකක් ආපින්ද වැරදි නැතුව ඇති. Okay, then I'll move to question number 12. Question number 12, part A. Right hand side, tan inverse x plus 1 minus tan inverse x. Take angle alpha beta. Put tan inverse tan alpha minus beta. Expand this inner bracket. Tan inverse tan alpha minus tan beta over 1 plus tan alpha tan beta. Tan alpha okay, simplify 1 over 1 plus x into x plus 1 equal to left hand side. Consider the following series. Then tan inverse 1 over 1 plus 2. 2 means 2 times 1. Tan inverse 1 over 1 plus 2 times 3. Tan inverse 1 over 1 plus 3 times 4. Tan inverse 1 over 1 plus n plus 1. Then take this proof. Tan inverse x plus 1, tan inverse x. Here 1 times 2. Then x mean 1. Here x plus 1, then x mean 1. Then tan inverse 2 minus tan inverse 1. Here tan inverse 3, tan inverse 2. Here tan inverse 4 minus tan inverse 3. Here tan inverse n plus 1, tan inverse n. Then take this relation. Then simplify. Then tan inverse 2 cancel, tan inverse 3 cancel, tan inverse 4 cancel. It goes like that. Here cancel, then remaining expression tan inverse n plus 1, tan inverse 1. Then write here n plus 1 minus 1, 1 plus n minus 1 into 1. Then tan inverse n over n. Here minus asne. Here n plus 1 n plus 1 okay. Tan inverse n over 2 plus n. Tan inverse n over 2 plus n. Find the value of theta in terms of n. Therefore, theta n over 2 plus n. If the series continue up to infinity, find the value of theta would be if that tends to infinity. If n tends to infinity, theta tends to here 1, 2 over n plus 1, theta tends to 1. Therefore, tan inverse 1 equal pi divided by 4. Then tendency pi divided by 4. Yes, n. This is Sn, then S infinity. As n goes to infinity, here divide by n, 1, 2 over n, 1. Here theta goes to, n goes to infinity. මේක questions normal pattern වලටම නෙවෙයි තියෙන්නේ. ඔවා familiar කරගන්න. Okay, then part B induction question. Part B induction question. Well, part B 1/3, 1 over 3 square, 1 over 3 cube, 1 over 3 to the power n less than 1. When n equal 1, left hand side 1/3, right hand side 1, therefore left hand side less than right hand side, therefore true for n equal 1. Let's assume that the relation is true for n equal p. Then 1/3, 1 over 3 square, 3 cube, 3 to the power n less than 1. Here this will be p. Now you need to prove this is true for p plus 1. Here let's do this way. You add both sides 1. Less 2. Now divide by 3. Divide every term by t now. 1/3, 1 over 3 square, 1 over 3 cube, 3 to the power 4, 3 to the power p plus 1, 2/3. Add both side 1, then divide by 3, then we can get left hand side again. Proof. Then here it is less than 2/3, that means less than 1 surely. Therefore, true for n equal p plus 1. True for n equal p plus 1. Therefore, by the principle of mathematical induction, the relation is true. The relation is true. Likewise, you can complete. That is question number 12. Complete. ඔයාලා මේ question එකම මේ මෙන්න මෙතෙන්ට 1 over 3 to the power p plus 1 add කරගෙන යන්න අරගෙන ගිහිලත් කරන්න පුළුවන්. හරිද? 1 over 3 to the power p plus 1 add කරලත් යන්න පුළුවන්. හරිද? මම මේ කරේ 1 add කරලා 3 එකෙන් divide කරා. ඒ වැඩේම තමයි වෙන්නේ. එහෙම කරත් තව පොඩ්ඩක් අපි ඉස්සරහට පොඩ්ඩක් හිතන්න තියෙන එච්චරයි. තව එකම question එකක් මම discuss කරන්නම්. question number 14. question number 14. Limit x goes to 0, 5 plus x square root minus root 5, 20 plus sine squared x minus 20 root. Limit x goes 0, multiply by conjugate, then 5 plus x square minus 5, multiply by conjugate here, 20 plus sine squared x plus 20 minus 20, here 20 plus sine square x plus 20 root 5 plus x square plus root 5. Then simplify. Then apply theorem for this. Limit x goes to 0. Here this part 20 plus sine squared x 20 root 5 plus x square root 5. Limit x goes 0, sin x of x square. For this one, then here theorem apply. Here you can substitute directly. Root 20 plus root 20 for this. Root 5 plus root 5 for this. And here 1 square. 2 root 20, 2 root 5. Answer 2. First part. Irrational type, no? Then multiply by conjugate. Then after that, evaluate the limit. Then y equal a e to the power minus kt cos pt plus c. Need to differentiate twice. dy over dt, a constant e to the power minus kt into minus k cos pt plus c plus e to the power minus kt into cos derivative minus sin pt plus c times p. Then dy over dt, a k e to the power minus kt cos pt plus c. Put k outside. Minus pa e to the power minus kt sin pt plus c. Okay, then for this part you say y. Then dy over dt equal ky minus pa e to the power minus kt sin pt plus c. Then differentiate. Again d square y dt square. Here k dy over dt. Then here minus pa take outside. Equal k t into minus k sin pt plus c plus e to the power minus kt cos pt plus c times p. Now it is okay. D squared by dx dt square. Here k dy over dx. Here minus plus p k a e to the power kt minus sin pt plus c plus minus p square a e to the power minus kt cos pt plus c. Here this is y again. Then for this part, PA right KP PA for this part PA e to the power kt sin pt plus c, subject this k dy over dx dy over dt k PA e to the power kt, subject ky minus dy over dt minus නැවතන p squared y, p square y. Now it is okay. Then d square y dt square. Here 2 k dy over dt minus k square y p square y, k square plus p square y 0, k square plus p square 0. Need to differentiate twice. minus එක මිස් වෙලා ගිහිල්ලා තියෙනවානේ. Okay. The last one. An object moving in the clockwise direction around the circle x square plus y square equal 1. As it passes through the point, here the circle, it passes through the point 1 over 2 root 3 over 2. Y coordinate decreasing at the rate 3 units per second. Then rate need to find. To find rate, differentiate with respect to time. 2x dx over dt, 2y dy over dt 0. Then here x variation rate, here y variation rate. Here given y coordinate decreasing at the rate 3 units per second. Okay. Therefore, subject y dy, subject x dy over dx over dt minus y dy over dt of x. Then here x rate. dy over dt, y coordinate root 3 over 2, x coordinate half, y decrease in rate 3 units per second. Then dy over dt 3 decreasing, therefore we better to put minus 3. Then simplify 3 root 3. Then dx over dt, x increment rate, three root 3. Y decrease in rate, then x increment rate. Y අඩු වෙනවා, x වැඩි වෙන එකයි වෙන්නේ. Then that is 3 root 3. To get rate, need to differentiate with respect to time. That's it. Okay. Complete that. That is question number 14. sum.